Welcome, everybody. I'm Kathy Grice, Senior Program Director in IEEE Future Directions. I welcome you to this wonderful live event on sustainability. We have a lovely panel of experts. Just some reminders logistically. This event is being recorded and will be available for on-demand viewing at a later time. Our slides will not be shared, but you can access the slides via the recording. For any technical difficulties or basic questions, please use the chat feature, but we really welcome all your questions and comments. Please post them in the Q&A feature. Thank you very much, and I will turn it over to you, Tom.
Thank you, Kathy. Thanks, folks. Glad to have a chance to talk to you today. So I'm Tom Coughlin, and I'm going to be the moderator for our session here on IEEE Building the Technology Path to Sustainability. So first of all, just a little bit about IEEE. Our core purpose is to foster technical innovation and excellence for the benefit of humanity. IEEE is a large organization with a lot of different pieces. Just a little bit of information for those that don't know about the IEEE. We have over 420,000 members worldwide in over 160 countries. We have 46 technical societies and councils that focus on different technology areas. That's their fields of interest. We have over 100,000 student members, again, globally. We also are a large source of technical information. We have convening. We do over 2,000 annual conferences worldwide. We have over 5 million technical documents. We've got over 200 top-cited periodicals and over 1,200 active standards. And I might also add that IEEE is the most cited source in patents. We also are involved in global public policy, humanitarian efforts worldwide in various ways, and we are a source of continuing education, especially on the lines of technology, ethics, and applications. We also have certification programs for some of our education, and we're very involved in the technology and ethics and technology. For example, there's a major effort going on in standards and elsewhere with regard to ethics and artificial intelligence. So there is IEEE has dedicated programs of various sorts, and every year the president of the IEEE can create ad hoc committees. There's a current ad hoc committee that was formed by President Saifer Rahman to address the global crisis of climate change. This committee, the ad hoc committee, is looking at how to mitigate its effects through pragmatic and accessible technology solutions. These are things that engineers, practical people can presumably act upon and discuss and come to some ideas and agreements on these. So this committee that was formed is called the Ad Hoc Committee to coordinate IEEE's response to climate change. And again, it's to identify ongoing efforts across the IEEE with key external partners as well for a comprehensive response, and to bring all the different parts, or at least be knowledgeable about all the different parts of IEEE and what they're doing in these areas. There's other activities that are going on as well, ad hoc committees, and many of these are going to be implemented, or some of these are going to be implemented into the activities of that board of directors ad hoc we just talked about. They include the Patent Positive 2030 initiative, which is a global open community of experts and stakeholders looking at developing recommendations to achieve basically a flourishing future that takes into account issues about sustainability, climate change, etc. There also is a joint organizational unit, IEEE organizational unit on sustainable development, which has actually been going on for several years, looking at things across the IEEE, trying to coordinate, promoting technical solutions and applications for sustainable development. And then there's an IEEE Technical Activities Board. That's where all those societies and councils sit, which has a climate change program to get these various societies to collaborate, develop holistic ways to address climate change, mitigation, and adaptation. And so engagement in support of sustainable development, environmental stewardship, and addressing the challenges posed by climate change is important to IEEE and to our members. Here's a sampling of some current activities. We have standards development on various standards. We have something called IEEE Smart Village, looking at sustainable energy for underprivileged people in various parts of the world. We have an IEEE humanitarian activities program called SITE, which exists in various chapters in local areas around the world, doing local humanitarian projects. There's an activity on sustainable ICT, and also IEEE standards activity has an industry connections program. And again, has been very involved in these efforts with regard to sustainability. And this current webinar we're doing now is actually put on by the IEEE Future Directions Committee, which is involved in technical road mapping and the development of exciting and interesting new technologies that will impact the course of the future. And we also have a PELS, that is Power, which is one of the IEEE Society's initiative to empower 1 billion lives. So with that, if you're interested in participating in any of these activities, you can contact Samina Hussein, whose email is here, as well as Mikey Lucan, who has been a very energetic volunteer working in this area. So with that, we have our event going on here today, and Wee Jen Lee will be our next speaker. Thank you very much.
Good day, everybody. And today I would like to, as Tom mentioned, there are several IEEE program or ad hoc or initiative related to the climate change program. And today I'm going to give a brief introduction on 2 of them. And one is on the IEEE Technical Activity Board Climate Change Program. And for this one here, it was established by Bruno Meyer last year, the VP for Technical Activities of the IEEE. And then the goal for this committee or for this program is we try to create a platform for collaboration of multi-societies to have a create a holistic program for the climate change mitigation and adaptation. So what we try to do is we try to integrate it, because when you look at the different society, they have a different the expert of domain, and then for their activity, a lot of time, sometimes they focus on their expertise, and then that create a little bit silo or separation among different societies. So what we try to do is we try to integrate the component device into the system. We try to integrate in the hardware, software, and the firmware. And then we also look at the technology, policy, and the humanity, because the IEEE, we develop technology for humanity. And then we also like to identify the best practice and also developing the joint standards. Then, as we know, the current technology would not be able to reach net zero carbon emission by 2050. So there's new technology has to be, and the tool have to be developed. And the IEEE is the technology know-how, and then the powerhouse here. Then we have the capability and also the responsibility to develop enabling technology. And then the other one is, okay, the dissemination information, because the education is the very important one, that people have to aware of the situation in order to act on it. And of course, with the climate change, we are going to see a lot of new technology come up. Then the workforce retraining and workforce development is very important task for us too. So currently we have more than 50 members from more than 20 different OUs. So on this one here, and then the first step we try to do is we try to understand what the different society have done related to the climate change mitigation and adaptation. So I kind of color coded. You can see here we have collected 8 society. They have provided their activities on the climate change related conferences or publications. And for this one here, of course, this is I call this one is a living document, because everybody is working on something, and the new activity evolved. So this is basically it's an ongoing process. So we like to understand everybody's activity, and then so on this way here, as the Tom mentioned, that we are also trying to create a road mapping over there. We have to understand what we are currently, what is our current situation and what is our end goal and how to build a roadmap to reach the end goal. So in the 2022, we have 4 initiatives. We try to look at it on the wildfire prevention, detection, behavior prediction, and then also mitigation and control. Then the other activity is the education content and the workforce development. We have the basically sponsor some design contest like a YESIST 12, and for the young, basically reach out to the young generation. They've then aware the urgent of the climate change issues. Then the other one is on the agriculture side, which we are looking for the food, water, energy nexus for sustainable development. Then the last but not the least is the sustainable technology, and then we are looking for the circular economy. Of course, the basically when you are doing something and you have to understand what is the current situation, what is your end goal, and then you can build up the roadmap. So on this way here, then we try to identify where is the the gas emission, the source, and then how can we create the mitigation and the adaptation roadmaps. On this one here, for our program here, we are actively looking for the member to participate. So this is, I will give you an open invitation. If you are interested, please contact me or the IEEE staff here, and then we'll include you in our activities. So yeah, for the current activity, the recent activity here, this is one of the sample. We team up with the CAS and then try to look at from the food agriculture side or from the food supply side. And then I gave a presentation on the honeybee monitoring system, and then try to make sure you give an early warning system when the beehive is in trouble. So on this way here, we can improve the food security. Then the other one, the planned activity here, then we are going to have a utility practice on wildfire prevention. And we have lined up the 3 different topics: the vegetation management, fire prevention of battery storage system, utility practice on wildfire watch out. And for the education, then we are going to continue support the YESIST 12 this year. And then I will let Mikey to introduce or to announce this one here. We have a climate technology sustainable initiative from the FDC. So I'm also wearing the other hat that Tom mentioned, that the CCIRCC, and I am a co-chair for the outreach subcommittee. And so myself and Teresa Bernasso, that we both co-chair this subcommittee. And currently, my assignment is outward, reach out to the non-IEEE society, the organization, and then try to include them in our activities and try to work together. So currently, we reach out to the young professional within the IEEE, and then also reach out to IEEE outreach activities. And because on this way here, when you talk about a lot of activity or the climate change issues, Africa is always on the radar scope. So I reach out to the Region 8, and then I also reach out to the United Nations Council of Engineers for Energy Transition. And then Mikey and El Pash from IEEE SA and the Rudy Schubert, and then myself, we have a discussion with the CET and how can IEEE become their technical support. And then I also reach out to the ASCE, American Society of Civil Engineering, and then that basically, just surprisingly, they have a lot of members, also IEEE member here. So this is the very good collaboration point, and then we can work together. So with that, I will conclude my presentation, and then after if you have any question, you can send it to the question, and also we can answer it after all the panel have their presentation. Thank you.
Thank you very much, Wee Jen, representing TAB. And our next speaker actually is Clara Neppel. who is the Senior Director of IEEE European Business Operations. So Clara, if you'd like to start your share. Thank you.
So thank you, and thank you for the invitation. My name is Clara Nettel. I'm the Senior Director of IEEE Europe, based in Vienna. And maybe from a personal side, I was always interested, I'm a computer scientist, and I was always interested in the contextual aspects of technology. So being in Europe, one of the most important aspects were the ethical part of, let's say, artificial intelligence. That's one of the contextual aspects. But of course, if we are talking about context, environment is an increasingly important aspect that we have to take into account when we design and implement technology. So here, the most important topic that I saw is that we have to take the context into account. We have, as technologists, to engage with the stakeholders that are going to use the technology, that are going to be impacted by the technology, in order to make sense. And I think I'm going to expand on the issues that Wei Jen just mentioned before, how IEEE is going to collaborate also with different partners in order to make our content contextual. So climate-related issues, of course, everybody knows are relevant to the general public, to industry, and public bodies. We see increasingly young people sitting together with scientists and, well, basically saying that we have to do something. The issue is urgent. We see industry that are also facing the challenges of how to implement the requirements, let's say, to environmental issues. In Europe, we will have a digital product passport, which is going to be used to document that you are basically engaging in sustainable innovation and development. And of course, also for the public bodies, it's going to be increasingly interesting that if we are integrating more and more renewable energy sources, if, for instance, our grid is stable enough. And of course, this is also something which is important for all of us, because we don't want to have a blackout. So all these issues are technical related. And the problem is now increasingly with fake news. We see the need to have a neutral, established and recognized organization as IEEE that can provide access to knowledge, access to people, that can be a collaboration platform, and really be increasingly a source of technologically oriented climate and sustainability expertise. So as I said before, we cannot do this alone. So as technologists, we cannot address climate change. So we need to consolidate our collective intelligence and to do this together. And I'm going again to expand to what Wei Jen just mentioned before and come up with this example on the wildfire prevention and wildfire initiatives that we have in IEEE. And I think that this content that Wei Jen just mentioned is going to be or could be interesting for the UN as well as for industry. I know that there is a big startup scene that is also engaged in these topics, as well as only in February this year, we had a report from the advisory board of the president on how to modernize wildlife firefighting to protect our firefighters. So as you can see, there is a lot of technical knowledge there, which needs context. And again, this can make a feedback loop to IEEE with new forms of engagements and the demand for new deliverables, which can be reports, metrics, tools, and so on. Here is an example of what we already did. In Europe, there is a regulation on how and different initiatives on how to reduce the greenhouse gas emissions by at least 55% by 2030. As you can see, there are different measures which come from renewable energy to energy taxation to alternative fuels and so on. As you can see also in the outside, I indicated where IEEE came up with position statements, engaging with policymakers to help them find fact-based decisions. And what is also important is to address these issues in the language which is adapted to the audience. So for instance, when it came to green hydrogen, we came up with infographics. We are increasingly going to use videos and so on in order to convey the message in a way which is best adapted to the audience. Here is an example of how we are engaging with industry consortia. In Europe, there's a Green Digital Coalition, which is an initiative of companies and organizations working towards reducing emissions. And IEEE was asked by the European Commission to contribute to develop recommendations on how to maximize basically savings and how to minimize emissions, as well as how to define metrics, enable data sharing, and of course, one of the big topics is how to upskill the professional workforce. We will need more and more these skills which combine technical, environmental, and societal aspects. And for this, we are also thinking of launching dedicated programs. So initiate a webinar series on how to advance technology towards a net positive planet, because the technology has both positive impact in the sense it can in the sense of how to address climate change. It also can have a negative impact. So the important thing is that the net impact is a positive one. And we want to do this with IEEE experts and partners via this contextual scenarios and expertise. And you can see here some examples of webinars. One of them was actually already this week on circularity and technology. And you can see also how we are engaging with in events also from different other organizations. And last but not least, I want to conclude, of course, that here we need to have a global as well as a local effort. And we are here very fortunate that we can leverage our volunteers and our sections, and also, again, partnering maybe with other organizations like UNESCO. Our young professionals could work together with UNESCO to work together to joint efforts and innovative activities, and show how even small steps in technology can make a big difference if it is adapted to the context. Thank you.
Thank you very much, Clara. Appreciate your input there. Our next speaker is going to be Rudy Schubert, who is the Director of New Initiatives at the IEEE Standards Association. So Rudy, if you'd like to go ahead.
All right, thank you, Tom. All right, thanks. As Tom mentioned, I'm from the IEEE Standards Association, and I'll talk a little bit about energy-related initiatives that we've got going on within standards. So first off, while we certainly do many standards, Tom mentioned over 1,000 standards are produced by the IEEE, a large percentage of them are power and energy related. So we have a very close working relationship with the IEEE Power and Energy Society, the Industry Application Society, as well as Power Electronics, all of which play a role in energy related standards. And so we have what we call our energy practice within the IEEE SA, because we're somewhat segmented into, you could look at it as different verticals. We have a focus area on telecom, we have a focus area on healthcare, several other ones. My particular area is around energy. So while we do keep a close tabs on the different standards activities that are going on, probably more importantly is we are always trying to look forward to what are the next generation of standards in the energy space that we need to focus on, and also for different collaborations that we could have with external organizations as well as our internal IEEE organizations. So we tend to look at the work in 3 buckets. It's kind of interesting that when you look across the wider IEEE, there are so many initiatives going on. It's so difficult to keep track of everything that's happening. Even if I look at Power and Energy Society, it has about roughly 20 technical committees, many of whom also have associated standards committees. So to try to simplify it in terms of the work that we do, we really broke it into 3 different buckets, and that's how we tend to do our work plans. So the first one is around smart energy, and that one is really looking at the topics that are very, well, they're all relevant here today, but smart energy gets a lot of attention. That's renewable energy, energy storage, smart grid type applications, microgrids, a lot of the newer technologies that are coming along. So if you look at that as the generation side of things, so to speak, the next bucket was more on the consumption side. So we look at where are the energy efficiency type areas. So we work closely with the IEEE Transportation Electrification Community, soon to be a council, I believe. We work with some of the vehicular areas of IEEE, looking at electric vehicles, their infrastructure. And interestingly, some of the sustainability work that you'll hear from Micah later with Planet Positive 2030 originally started under this particular energy efficiency area. However, it kept growing and growing. So now we've spun that out into its whole own area. And then the third leg that we have there is the energy infrastructure. And this is where many of the legacy IEEE standards come from. We have standards on everything from the wiring cable to the transformers to the substations. Just about any of the, what I always call the nuts and bolts of the power grid are covered in some fashion or form through IEEE standards. And those are, vitally important. So while so much attention tends to go towards wind turbines, large scale solar and everything else in the name of renewable energy, we still have to get the power from one place to another. And more importantly, we're having more and more to rethink how we get power from one place to another as we have a more distributed set of generation that's out there. So drilling down one level further, a lot of our focus currently, and this is because where a lot of our volunteers and a lot of the external opportunities are happening, is really two different areas. One of them, again, certainly on renewable energy. And the challenge is as we get to a higher penetration of inverter-based resources, as I noted, when it comes to infrastructure, things are changing. You can't necessarily have business as usual. You can't just keep adding things and changing the way that the grid is structured. So two of the key standards that we have are IEEE 1547 and 2800. Respectively, those deal with interconnection of, say, solar or wind to the grid. 1547 more on the distribution level, 2800 at the much larger scale transmission level. I know Mark Sira is going to speak in more detail on that shortly, so I won't get into all the details. But we do have a lot of activity going in those areas. When you do have all these inverter-based resources, there's a large need for energy storage. And again, there's a lot of standards activities that are going on related to the storage itself, as well as how you integrate the storage with all the other aspects of the grid. But in parallel to that, we're also looking more and more at the resilience of the grid. I know there's a lot of activity going on in Power and Energy Society, and now we're starting to see more of that migrate over to the standards area, because you can put out a lot of inverter-based resources, but it's going to take time. We talk about by 2030, 2050, all our targets that we have out there, that's still a lot. It's not a lot of time to get there, but at the same time, time is passing and we are seeing climate change in parallel to that. So the grid that we have today has to stay resilient in the face of, perhaps greater threats due to weather, as well as other threats that are out there. So that aspect is becoming much more interesting when you talk about resilience. Like, how do you measure resilience? How do you know you're getting more resilient? What do you have to do different in terms of equipment hardening? So it's a very vibrant area that we are just starting to get more and more involved in. The renewables, we've been doing for quite a while. Maybe we were a little bit ahead of our time, but resilience, I think, is becoming equally important, because we can't just assume that the grid is going to operate as usual as we go forward. So in addition to the standards that we are developing within the IEEE SA, we don't just write the standard and put it on the shelf. So we try to look for opportunities for helping people to implement the standards. And those could be in the way of education is one of them. We do a lot of different workshops around a lot of the different standards, really trying to help people understand not just what's in them, but how they're going to use them. And one of the recent areas we've gotten into is a credentialing program, which is really helping utility engineers to become, in a sense, certified to be able to understand how to apply the standards as they're integrating renewables into their particular utility. And that's a program that was started with a number of US utilities, and now we're starting to see more interest internationally as well. So associated with that international element of engagement, one of the things we've done in the past couple of years is IEEE has become a participant in the Global Power System Transformation Consortium. And this is a really interesting group. It was founded by a number of system operators globally. We've got some from Europe, some from Southeast Asia, really just the whole world is covered. So it's these utilities, a number of leading research institutes around the world, and IEEE has been involved in that. It's been SA, Power and Energy, IAS, all been very active in that. And just to get into a little bit more detail on that, IEEE's role is what we call localized technology adoption support. So a lot of it is, as I was saying, taking these standards that we develop and working particularly with developing countries who might not, they might be working in sort of a green field. They may not have done too much with renewables yet, or they might not have a workforce that is perhaps as well versed as some of the countries in Europe, might be a little bit more ahead. So it's really just taking those lessons learned from the countries that are farther ahead with their renewable implementation, and to share that with the world, particularly developing utilities in developing parts of the world that could greatly benefit from this. And so the work is divided amongst this consortium in 5 areas, with IEEE leading the part that is a little bit more focused around standards and their implementation. But that gets coupled with research. What research needs are there? And that's what you see in column 1. National Renewable Energy Lab is the facilitator of this entire program, and they do a lot of work working with other countries around the world. So they do a lot of the putting together of the technical stakeholders with some of the countries and the utilities, and as well as there's an educational aspect of it, that item 3 there, foundational workforce development, which really focuses on engineers of the future, college curriculum, really just trying to train the next generation of power engineers so that they are well versed in these technologies as they become more and more important. So it's a very dynamic opportunity for us to be involved in doing some work that really has a direct impact on system operators, and particularly for changing the grid in a lot of these different countries. Because it's getting to these goals. It's not just the big countries necessarily doing their part, but everybody really needs to be a part of that. And so we're really just trying to contribute the IEEE expertise as best we can. A couple of times in Tom's introductory comments, I think Wei Zhen mentioned it. I did want to touch that we have this Industry Connections program within IEEE standards, and that's really a platform that incubates new standards and new communities. I like to think of it as the next generation of standards get incubated through these groups that come together, and they're sort of think tanks in a sense, thinking about what do we need. And we have quite a few of them that are going on currently. I mentioned that the Planet Positive 2030 talk, which is coming up, actually originated through Industry Connections. But we're looking at some of the areas you see on the screen, maritime sustainability. So electrification of ports, electric ships is an interesting one. We've got one that's looking at supply chain and asset traceability. So, when you do, this really ties in well with the resilience theme, that when there's a storm and you need to have different utilities helping each other out, how do you know who has enough transformers or where they are? And it's really just a way of looking at the inventory that's available, that's installed, and having a better way to track things. As well as we're doing a bit with electric vehicles and mobile storage. So quite a few groups, and this is an opportunity in a very lightweight way for groups to come together on key topics. And sometimes these migrate to become other parts of IEEE societies. Some have migrated towards Future Directions, but it's a really good starting point for people who want to incubate a new idea. So, finally, I just wanted to bring up that, so many of our standards, as I mentioned, really touch on the core grid hardware, worker safety, just about everything you can imagine. And, as things continue to change, as we continue to evolve the grid, all of these are increasingly important. But when it comes to sustainability, so many of the other standards that we do across IEEE are also involved. So a lot of going on in communications and telecom areas, things going on from an agriculture standpoint, as Wei Jin pointed out earlier. And our standards volunteers are looking at how you can have standards that are supporting across pretty much every technology domain. While I tend to focus on power and energy, we have so many other things going on at the same time. And I just put the link in there. We'd be happy to encourage you to go check out the full range of work that's going on and answer any questions to tell you how to get involved in those. So with that, I will wrap up and I will turn it back to you, Tom. Thank you.
Thank you very much, Rudy. Appreciate talking about the standards and their relationship to the sustainability and climate change efforts. We also have another speaker representing Mark Sira, who is the chair of the IEEE Standards Coordinating Committee 21, and he's going to get into some more standards relating to sustainability. So go ahead, Mark.
Okay, thanks for having me. As it says on the screen, I'm the chair of a committee that focuses on distributed generation, energy storage, and interoperability standards. And I wanted to emphasize, how these standards get developed. My committee focuses on the interconnection and interoperability smart grid standards. We report administratively to the Board of Governors, but I want to emphasize that anybody can develop a standard project. We take an idea, submit a project to the new standards committee and of the standards board, and if it's approved, we have some time to develop the project. Once the committee develops and ballots the standard, it gets submitted to the standards board review committee, and hopefully it's approved. But I wanted to give you a sense for what the process we go through is. Why are they important? It is really important. I've seen the benefits over the last 30 years of participating, and that it gives us a consensus view of a balanced view of the industries and stakeholders, and people have to agree and come to consensus to make these standards work. And it's very important to IEEE that happens. It also establishes a common terminology. So as we start getting into these complex areas of the grid, we're using the same terms for the same things, and it makes the work a lot more clear. And over time, it develops modular solutions. An example of that I put here is when the 1547 standard was approved in 2003. Prior to that, an electric utility could require whatever they wanted if you wanted to connect to the grid, either a emergency system or a solar power system. And after those rules were established, it unleashed a rapid growth of the industry. So the controls could be developed into a fly-by-wire solution, electronic controls, programmable solutions, and it saw the costs in the industry go down over 50%, and the growth was enormous, 5 times growth over the first 5 years. So it was very dramatic, and then that was triggered by having the rules known on what we had to do. I'm going to go to the next one. Just so how these standards fit, they're listed as national codes and standards. They're mandatory standards, and the states work with various stakeholders to develop their individual requirements for interconnection. And the utilities and the bulk power system operators work to consolidate so their standards are consistent with this. I put a link up here. You can go and look at where these are being deployed and how fast they are moving forward. This is a partial list of the 1547 series interconnection standards, and I highlighted with yellow text the ones that are maybe of most interest to you. We're revising the 1547 2018 standard, and it was an aggressive timeline. We're revising it 4 years after it was published and approved. There's a shortly to be published application guide. That's going to be an excellent document for anybody to refer to that wants to connect to the grid. We are close to publishing a guide for cybersecurity of distributed energy resources. And then lastly, 1547.10 is a recommended practice for developing a DER gateway. So there is an intermediary device or system that can allow utilities to use their standards for communication and allow the equipment manufacturers to use their standards without complicating the industry. The 2800 series was a recently developed set of standards, and it paralleled 1547 in some cases, but it was developed for inverters connected at a high voltage transmission system. And a lot of the discussion and specifics are related to wind farms and large solar plants that are connecting to a bulk power system. We're also developing a guide for testing and verification. That's an active project, and if you're interested in that through IEEE, you can sign up to participate in that standard. We also have a very large number of standards developed as the 2030 series, but I've highlighted again that we have a project to revise the base standard, P2030. We have a guide that's shortly going to be published for control and automation systems, microgrids, and then lastly, we're hopefully going to have, well, this is actually just published, 2030.11, a guide for DERMS, Distributed Energy Resource Management System, to allow aggregation of distributed resources. And there's some new standards related to fast charging that are just getting started. I'm going back to our process with this slide. Once we have a project approved, we have 4 years as a committee to develop the standard, ballot it, and eventually come up with a draft that's submitted to the standards board and published. Occasionally you have to work for an extension, but we do have 4 years under the base rules. And then once it's published, we have 10 years before we should be considering a revision and submitting a revision to be published. So I just wanted to keep you aware of that. And as this industry change accelerates, we're going to see more and more where we have to start the process in less than 10 years to keep up with all the changes. One of the things we use is a technology roadmap to look at these. This happens to be the 1547 roadmap. We look at the standards where we have an active working group, we're developing a PAR, or we have a future working group. And this is based on timing. We also have some other activities, and we're working with Rudy Schubert's team to develop some understanding of the gaps where we need to change the priorities, not just on timing. This is a chart we published. That link I showed you has this material available, but we do track where the IEEE 1547 standards are being required by states, and the orange ones indicate that they're being reviewed by the public utility commissions. Orders have been developed in the blue states, and so we're tracking how fast these are going to be adopted. It doesn't look like, it looks like there's a lot of gaps, but if you look at the details of these states, these are the states in the US that are being very aggressive towards renewable energy, and we're trying to make sure these rules are required and available at those places. So I dropped a lot of information on you in the last 5 minutes, but there's a lot of changes underway. We have another revision of the 1547 standard, this DER gateway. We're developing the verification and test procedures. We have some other new standards that are going to be published shortly. 2800 and 2800.2 are getting a lot of visibility for larger scale systems. And we're looking at identifying gaps and possible new areas, such as for grid forming inverters. And those are inverter devices that can form an electrical island on their own, which presents a lot of opportunity. Interoperability guides for making sure the systems work seamlessly together, and continued evolution of cybersecurity. All right, and I'll have verification and testing and a lot of input on modeling. So that completes my presentation.
Thank you much, Mark. I appreciate your going through that additional information on the whole standards process and the opportunities as well. Just one thing I want to let people know, we got a few questions in, but we're open for questions when we're all done here. And for those that aren't familiar with where that's at least on my screen in the lower right-hand side, there's 3 dots. And if I click on that, then one of the options is the Q&A. So if you have questions for the panel as a whole or for individual people, why don't you go in there and be sure to post those. And anyway, and thank you very much, Mark. I appreciate that. Our next speaker is Christopher Witt, who is the president of the IEEE Oceanic Engineering Society. So go ahead, Chris.
Thank you very much, Tom. I really appreciate that. I'm going to speak on something a little bit more, I guess, I don't know, forward-looking perhaps. And I hope that will inspire a little bit of optimism for the potential for standards and technology to really enable sustainability. So it's the Planet Positive Initiative has already been mentioned a few times, and I'm part of that effort and leading a chapter on the ocean and coasts. And I'm going to talk a little bit about how the ocean is important for sustainability and ocean technology can enable sustainability. First, I'll start with a quote from the United Nations Secretary General Antonio Guterres. The ocean plays a crucial role in the achievement of the Sustainable Development Goals and the livelihoods of billions of people. We urgently need to change how we interact with it. So in the Planet Positive book, Strong Sustainability by Design, we start each chapter with a future vision. And the future vision we have is that in our, in a realistic time frame, the application of technology can substantially change how we manage and benefit from ocean ecosystem services and resources. So just to recap a little bit why the ocean is important. The ocean provides the basis of the livelihoods for millions of people, and it's responsible for about half of our global primary production of oxygen and nitrogen fixation. It's also not perhaps widely known that about 90% of the deep carbon storage for the planet is in the ocean, in the deep ocean. Of course, we do probably appreciate that ocean ecosystems provide coastal and storm protection and opportunities for tourism recreation. Seafood is essential for food security and energy. According to the OECD in 2016, about 1/3 of the global energy hydrocarbon production came from offshore, and the future potential for offshore renewables is probably of a similar order of magnitude. Not just energy, but economic impact. Again, the ocean economy in 2016 was estimated it could double by 2030 to more than $3 trillion and 40 million full-time jobs. How do we impact the ocean? Well, the ocean has absorbed 30% of all CO2 emissions in the past 100 years, and that's increased. That's resulted in a commensurate increase in ocean acidity. The Earth climate system is a cycle of energy between the ocean and the atmosphere. And the energy in the ocean is kind of like the fuel in the tank, and the fuel in the tank is increasing. How is it increasing? Well, over the past I had 100 years here, but I think actually the statistic is 70 years. Over the last 70 years, 90% of the excess heat energy that's been added to the Earth climate system has actually been absorbed into the deep ocean. So the temperature of the deep ocean has risen a tiny little bit, but that's been 90% of the energy over the past 70 years. And the best science on that right now is that the energy added to the ocean over that time period is on the order of 400 zettajoules. And I don't know about you, I'm pretty good with SI units, but I don't really have a concept of what a zettajoule is, or I didn't. So I'll give 2 examples. If you add up all of the energy consumption on the entire planet, everything, coal, gas, energy, oil, gas, electricity, everything, that adds up to about half a zettajoule per year. 400 zettajoules over 70 years is about 6 zettajoules of heat added to the ocean per year. So for every unit of energy we consume as an entire planet, 12 times that amount of heat is added to the ocean by the greenhouse effect of CO2 in the atmosphere. Another way of thinking about it is, I think I heard someone say it's roughly equivalent to 3 Hiroshima-sized atomic bombs going off every second for the past 70 years. So the ocean is really buffering the climate system. But that thermal stress is accelerating sea level rise, it's creating deoxygenation, it's accelerating coral bleaching, powering storm formation, causing sea ice melt, polar migration of marine animals, and lots of other effects. And the marine heat waves, I mean, this is internal to the ocean, not just atmospheric weather, but marine heat waves in the ocean are interrupting not just biology, but also physical oceanography, so ocean currents and mixing of nutrients and processes in the ocean. How does that affect us? How does that affect people? More than 600 million people live in coastal regions that are less than 10 meters above sea level. Nearly 2.5 billion people live within 100 kilometers of a coastline. And those regions are generally experiencing higher growth and higher urbanization. I mentioned earlier food security. More than 20% of animal protein for half the world's population is provided by sea resources. And in some places, particularly developing countries, that proportion is much higher, more like 50%. We already know that most goods and services are transported by sea, and we've heard lots of things earlier about ways that our members are working on efforts to make those things more efficient, but it still impacts the ocean. And of course, all these impacts are not just for those that are close to the ocean, because biodiversity, storm hazards, sea level rise, food security, energy security, and all those things affect everyone. So what do we know and what do we don't know? Well, there's a lot of gaps in understanding how the ocean provides these benefits to the climate system and how we can best use the benefits that the ocean provides. And the key thing to realize is that studying the ocean is different than almost any other thing we do. I mean, probably many people appreciate that the ocean is a really harsh and unforgiving environment when you talk about people and equipment and ships, but it's also opaque to electromagnetic waves, which means that most things we're familiar with, whether it's radar or imagery or GPS or radio or Wi-Fi, none of those things work within the volume of the ocean. So satellites, yes, can reserve the surface of the ocean and maybe even the first few meters of the surface. And on a clear day, if there's no clouds and you have some good image processing, you can infer lots of things about that top few meters. But we can't really effectively measure all the things going on within the volume of the ocean. Where is all that phytoplankton? Where do all the other food webs actually move, and how do we impact them by the activities that we have everywhere in the ocean? Another sort of different but similar point is we often hear a soundbite that we know more about the surface of Mars than the ocean, or maybe more about the surface of the moon than the ocean. And that specifically refers to the lack of a detailed bathymetric map of the ocean floor. So if you open up Google Earth or some other mapping software, you'll see a nice sort of contoured images of all the blue areas. That's really, really coarse. That's derived from gravity measurements that's, again, provided by satellites. A detailed map like you have of Google Maps of your neighborhood just doesn't exist for about 78% of the ocean floor. And that lack of detailed mapping affects our modeling of physical oceanographic processes and biological processes. It affects marine planning and resource management. It affects efforts to restore the environment and to increase economic development. So that's just one example of how throughout the ocean we have extremely limited knowledges of where the processes, both physical and biological, happen. We do have models. There's really good models out there. They are improving, but they're still limited by the data that we have to validate those models. And a lot of the data we have is at the edges. Now, again, another different and complementary challenge is that large areas of the ocean are beyond national jurisdiction. And so they consequently lack effective management and monitoring and protection. Now, there was a recent treaty through the UN, the High Seas Treaty, and that's a crucial first step. But like any bilateral process, multilateral process, it's just a starting point. It's barely providing the framework to start working on measuring, monitoring, managing. There's still lots of work to do. So then the end of the story, the optimistic part, how can technology and standards help? Well, we know from lots of other domains that technology and standards can drive down the cost of automated systems and sensors. And that sort of thing is just what we need to effectively measure, monitor, and manage the huge, vast, unmonitored, unmeasured volume of the ocean. That can enable all kinds of things: better ocean science, more efficient marine transport, more affordable renewable energy production. And standards and policy frameworks can be complementary, so that there's a growing effort or growing industry of autonomous vehicles that are being used mostly these days in science applications or maybe defense applications. But just a few weeks ago, the first fully automated cargo vessel made a trip in Norway. And the rules around all that are still to be developed. So standards is well understood by our community in the technology area, but we also have to work together with the policymakers to enable effective use of technology to address sustainability challenges. A really big opportunity is direct climate change mitigation. So all the pathways that allow us to reach the IPCC goals by 2050, net zero 2050 and all that, involve the use of carbon dioxide removal in some significant way, at least 100 to 1,000 gigatons within this century. And that's several orders of magnitude above and beyond what we have the capability of doing right now. But again, the ocean is the biggest carbon store on the planet. So ocean-based technologies have a potential to play a huge part in that carbon dioxide removal necessity. The technologies for it are very immature, but that to me sounds like an enormous technology opportunity and economic opportunity. I think of it as, if you imagine all of the oil wells and all the drill rigs and all the oil tankers that have been going around the globe for the past 70 years, powering our civilization. You take that whole pipeline and turn it in reverse and find ways to take carbon out of the atmosphere, maybe chemically, maybe biologically, maybe other things. But there's a whole industry around designing, maturing, building, and scaling up those technologies, that same amount of stuff back in the ground somehow. Not just the actual technologies for CDR itself, but for all the other things, the food security, the energy, the economics development, all those things need remote sensing, need communications, need machine learning and AI to enable the measurement, the validation, the verification, the management of all of the ocean resources that we need to achieve sustainability. So that, I think, is the end of my talk. Thank you very much.
Thank you very much. Thank you very much, Chris. Our last speaker before we go to the questions is Maike Luken, and she is the chair of the Planet Positive 2030 initiative and is also involved in IEEE Standards Association. So go ahead, Maike.
So thank you very much, Tom. And yes, I'm going to conclude the presentations. Planet Positive 2030 initiative. This initiative was started about 14 months ago. And as mentioned earlier, it's an initiative of the IEEE Standards Association. And I have the privilege and honor to lead it together with John Havens. He is the IEEE SA staff lead on this project. So we all are aware of our context, really. We have a number of huge challenges in this century. The climate emergency is, in my personal opinion, the most important or the most urgent, but that's highly debatable depending on what point of view you take, because there's many other huge challenges associated with sustainable development around the globe. And for example, the lack of ubiquitous access to potable water, the growth of the mountain of waste that we are producing, the lack of equity and inclusion, the lack of resilient energy supply for all. We have still people who are not connected to the internet, about more than 30%, 35, 36% around the globe. We have lots of people who do not have access to electricity. So we actually have a bundle or a huge group of emergencies, crises, challenges that we need to address. And I'd like to quote Mark Carney from his book Values. He essentially points out that there are three types of technologies or innovations that we need in order to address these challenges around the globe, these crises. And one type is engineering technology, the second is political, and the third one is financial. IEEE, of course, based on its expertise, the expertise of all its members, is around the engineering and technology. However, whenever we are looking at solutions, we do have to take the context into account, be it political, financial, local, geographical, etc. So the challenge is to come up with responsible mitigation and adaptation measures that will limit global warming and further ecosystem destruction. And we need this for the well-being of people, animals, the plant life, essentially in order to have a healthy, flourishing planet for today, tomorrow, and the long-term future, for generations to come, for a sustainable future for people and planet. We cannot be solely people-focused or human focused. We do have to take the entire system, the ecosystem around, or the biosphere, if you want to say it that way, around the globe into account as we develop measures and as we measure the impact of measures that we are taking. So we called the initiative Planet Positive 2030. It's an initiative that's an open global initiative to focus on developing practical paths to achieve the sustainable planet, a planet positive future for 2030 and beyond. So practical also meaning contextual. And why do we use the word positive? What do we mean by planet positive? Is that effectively it is not sufficient to come up with a plan that yields us climate neutral. We need to be regenerative. Our solutions have to be regenerative and give back. Not harming the biosphere, but actually regenerate the various biospheres where required, and ultimately result in a circular economy or circular economies. So we set this out as two impossible goals, as we call them, to transform society and attitude and infrastructure to achieve planet positivity, and then identify technological solutions that we need to implement, some that we have already, and some that we may have to develop in order to address technological or technology gaps. So implement and deploy in order to reach Planet Positive 2030. Somebody asked me yesterday at a seminar, why we do use the word 2030? Well, if we aim for 2050, we do need to have a goal that's interim. Otherwise, we may actually wait too long. So we really have to be on the path to achieve the IPCC goals for 2050. We can only implement them if we have interim goals for 2030, 2040, etc. So hence our focus on 2030. Also, of course, because the UN SDGs have a 2030 goalpost. We divided this project up into two projects, one to generate what we call a compendium, Strong Sustainability by Design, and I'll mention a few things about that after, as well as a impact accountability or assessment framework, Accountable Sustainability by Design. Whatever we do, we have to measure the impact in order to make decisions to continue or to change, etc. So let's talk about the compendium a bit. We call it Strong Sustainability by Design, and it is focused on ecosystems. So the start out, and we heard Chris talk about the ocean and coasts, or in this particular case about the ocean. Truly, we look at starting out from the ecosystems, look at what this ecosystem should look like, in the future, and then backcast to today and identify pathways on how to get to this future vision. So the compendium right now contains around 400 odd pages. It has overarching considerations like economics, metrics, global methodologies, the arts, and ecosystems-based chapters that result in recommendations for each of those chapters. Within each of those chapters, recommendations to issues that are identified in these different parts. The approach is multidisciplinary and using a backcasting process. And the participants are really from around the globe, from over 20 countries, and from many different disciplines. And here's a little bit more about that. There are about 400 individual participants. You may have a look at the bios if you so desire. And it is not just the collection of the collective wisdom of the participants in these documents. It is also using a language that is accessible. And I believe Clara talked about this earlier with respect to green hydrogen. We need to express the knowledge in such a way that it is accessible to the stakeholders that want to implement projects, make decisions, and so on. I mentioned earlier, we need to measure what matters. We have identified one project. It's called Basic Sustainability Assessment Tool to measure the progress of a small or medium-sized company, enterprise, organization on its pathway to become a contributor to overall sustainable development, as opposed to the tools that are available to large companies. Other timelines, as I mentioned, we started in early 22. We have had 2 draft versions that were discussed of the compendium that were discussed at a couple of face-to-face workshops last year. We are currently working on the 3rd draft, and it will be available for public input in the end of May for a few weeks. Then that input will be incorporated by the various committees, and we are aiming to have a version, of a first version of this compendium available early November at the earliest, early January at the latest. And of course, this is a living document, so there will be updates, and we are working on a way to collect continuous input and updates. Already mentioned, there's always new collaborations and new activities happening. So we have a new initiative in the Future Directions program, Climate Technology Sustainability Initiative. And it works hand in hand to a certain extent with Planet Positive 2030, as well as with the TA climate change program to work together to identify further roadmaps, technology roadmaps, and standards and other opportunities to share the knowledge that we are developing and accelerate the sharing of this knowledge so that people who are working, communities, stakeholders that are working on implementing climate change and SDG related measures have access to information faster. How to participate, as mentioned earlier by many of the participants here, is there are lots of activities. Please join any one of them. And also, don't be shy about proposing a new initiative. And with that, I'd like to thank you all. Thank you for your time. And Tom, back to you.
Thank you very much, Mikey. And we're going to go to some of the questions we've got right now. And by the way, for those who are participating here, there's been some online answers to questions that you can check out there as well. If you go to the Q&A, there's answered ones, and you can see the comments that have been made by some of our participants. There's one here I'd like to put out here that actually is in that answered right now, but I think maybe there's more comments that can be made. Given its connection with power and engineering, I can understand IEEE's focus on climate change. Is there any role for IEEE in the related problem of biodiversity loss? And by the way, the rest of the participants, you can come back online and with your voice and image if you want. So this is with regard to climate change and questions of biodiversity.
So if I may, Tom,
Yes.
Biodiversity is certainly a part of the climate of the Planet Positive 2030 initiative, and it's expressed in various recommendations.
Okay.
Not only biodiversity, but also the 3030 program for protection of ecosystems.
Okay, thanks. Thank you.
I think I kind of touched on it a little bit too, and
yeah,
probably there's direct answers to the question, but there's certainly a lot of indirect applications of technology. Remote sensing of all kinds can be used to measure and
good point,
to monitor and manage biodiversity and impacts on biodiversity. And then there's lots of things too, like offshore wind farms have turned out to actually improve biodiversity by forming habitats for certain kinds of fish, and they also sort of reduce, like they cordon off areas that aren't really accessible for certain kinds of resource extraction, like fishing or other kinds of energy extraction. Coral reefs is another example. Like there's all the concern about coral reef bleaching, but then there's technologies of using synthetic structures to grow new corals, and then using AUVs or robots or subs to then place those over wide areas. So there's definitely lots of applications where technology can enable biodiversity, and not just in renewable energy.
Oh, okay. Anybody else have a comment on that? Okay, there's a question for Clara. Is there any effort to with regard to scientifically or technically understand the evolutionary nature of global climate changes dating back to 100-year cycles or any other cyclic events? In others, are there any patterns there that you know about? And Clara, if you don't know the answer to that, if anyone else has a comment on that.
Yeah, sure. Well, I think that is exactly the point I wanted to make, that it is important to work together with environmental research institutes. So there is a scientific answer to that. There is already research going on, but there's also a technical part to that. As you know, with data and with artificial intelligence, for instance, there are, of course, new ways of making that assessment. So this is also the part where we have to, can work together with different institutes and public bodies that are engaging in that effort. And it is part of the assessment and the measurement that Mike also referred to.
Okay, thank you, Clara. Anybody else have a comment on that? Okay, got another one here. To what degree are IEEE, let's see, change initiatives focused on technology development versus deployment of technology into local and global field programs? Anyone have a comment on that?
I think Regen, unmute your please.
Yeah, okay, yeah.
There you go.
That
yes.
Basically we understand that different region has a different resources and also the different constraint. So from the IEEE outreach point of view, we try to reach out to the different society and started from the grassroots on the local area, and then try to identify what they need and what are the constraints, and then also sometimes there was a local policy and the regulation. So it's not a one size fits all technology, and then we would like to basically tailor it, and then with the basically it's not to tell people what you need. We just let people tell us what they want, and then we provide a solution for them.
Okay, thanks, Bijan.
And if I may, I think more generally in IEEE you will find everything. You will find, you know, how it's a life cycle approach, because we, I mean, you, the members, were engaged from research to deployment and standardization. So we will also address the design and development, and how to come up with recommendations and principles of what to take into account as a developer, as an engineer, when you're working on you know, on this technology, and in order to make these environmental aspects into account already at that stage.
Okay, thanks, Claire.
I have a comment on that.
Go ahead, Mark.
There are some efforts going on to, a lot of modeling efforts have been happening to try to capture the data on climate change, for example, extreme low temperatures or extreme wind events. And then in parallel to that, they're trying to track where failures in the electric power system have occurred, and then eventually be able to pull the models together so we can predict that. But it's a very systematic approach that's starting to happen. Really great question.
Thank you, Mark.
So if I may,
Sure.
we are just inviting participation for a new recommended practice and standards, and that is on building a technology or digital technology commons, and a platform. So developing a standard for this type of platform to share knowledge close to the application. So as Clara pointed out, we have essentially information and knowledge that covers the range from very new, far into the future type theoretical research, all the way to standards and then to applications. And the closer we get to the application, more contextualized that knowledge is. And so we're looking at what is the best way of sharing this contextualized knowledge that is often geographically bound, actually.
Thank you, Mikey. I've got, here's a good question, and I think I know the answer, but you guys get to talk about it. How will young professionals be involved in this initiative for a sustainable future? Because they're going to be the most affected by the future climate changes. Go ahead, folks.
Well, the young professionals are, I think, are really very active. There is a young professional task force, and they are engaging in different activities. You know, from working with the regions to engaging with international organizations. So I think that we see the young professionals as being the youngest one, the most active one, and also engaging, I would say, non-IEEE members. That's also the idea to join forces with other young people and create maybe new forms of engagement. And make something constructive with all the energy, you know, becoming from a climate warrior to a climate warrior. I hope I said it, but basically doing something constructive. And I think it's a really good initiative.
Anybody else?
For the young professional, and we have seen a lot of activity from the young professional, and then they express the concern on the climate change issues. So from the TAP climate change program, we have reached out to the young professional group, and we basically discuss with them and then invite them to join force with us. I believe that is in the joint OU Sustainable Development Ad Hoc. We also invite the women and engineer, and then also the young professional to join the discussion. So I think that we try to bring everybody on the same page, and then try to have a collective effort, then to tackle the climate change and adaptation, the mitigation and adaptation problems together, because they are important in the process. And as you say, they will be impacted by the climate change issue the most. So that is the basically, okay, well, we have a common goal, and then we can work together.
Thank you. Thank you, Mead.
Mark, I just got a thought on that. I mean, I briefly touched on it in my presentation, but anybody can propose a project that becomes an IEEE standard and either get involved in one that fits the area of interest or come up with some ideas and start a new project. So that's what it's all about, is consensus. Thanks.
Thank you. Thanks. Yeah, actually, you know, go ahead, Mikey.
Well, actually, I would like to put it in a one very short phrase. We count on the young professionals to be able to succeed.
I think that says it all. Okay, I've got an interesting one here. So the concept of a circular economy where you can reuse, you could use stuff again or recycle things is a part of this whole sustainability. So the question is, are there standards, or could there be standards tackling jointly the circular economy objectives in energy system requirements? So I guess this would be one on the standard side. Any comments on that one?
Yeah, I can jump in for a
Thanks,
second.
Rudy.
And Micah might want to weigh in too, because she mentioned, I think early on, that there was this sustainable infrastructures community program that we have, and that has had a thread of circular economy in it. A lot of it, I will say, is more the discussion phase right now. I mean, everybody seems to recognize that this is very important. Making that next step to standards, I don't think we're quite there yet. I know not IEEE, but I know ISO, another standards development organization internationally, has a general circular economy, but I think that, again, it's very general. It's not energy sector specific or any particular technology sector specific, more of a framework. So I could certainly see this coming over time, but right now I think people are just trying to get a handle on how you actually do it in a structured way. Micah, maybe you might have some further thoughts on from the group.
Yeah, so not necessarily IEEE, but I've had a little bit to do with a center of excellence that is working on the end of life of electronic waste. Okay. And so one of the problems they had to solve was how to distinguish between 3 different kinds of black plastic. They've managed to do that. Another piece they had to look at is, okay, if you're recycling a cell phone, or like the cell phone is at the end of life, it cannot be used anymore. It now needs to be taken or reused or repurposed, now needs to be taken apart. So because of it cannot even be shredded because the battery might cause it to explode, right? So it has to be taken apart. So we could come up with guidelines on how to build devices so that they're actually not just repairable. We have the repairable legislation coming forward in Europe, the right to repair, but also to be able to take it apart.
Yeah, I was
So
going to say there are, yes.
Sorry.
Oh, go ahead.
Yeah.
Go ahead, Rudy. Then Clara, go ahead.
Sure. There is a series of standards that did electronic products, as Micah mentioned, the 1680 series. But I think when you get to bigger scale things, that's where it really becomes interesting.
But the issue truly is, okay, so take it apart and then identify the materials, go away from compound materials like gluing plastic to paper, for example. So on the one hand, how to build things so that they're easier to be taken apart, and then if they are easier to take apart, then you can take the materials and move them back into feedstock for new parts. So that's the ultimate goal. And somewhere along the line, as Rudy was saying, we have it for particular items, but we also need it overall for any type of widget that we are using, whether it's electronic or whether it's a spatula in the household.
So just a quick example.
Yeah,
Oh,
just to
sorry, Clara.
complement it.
Sorry, Clara.
Yeah. So we just had a webinar, actually an event, a hybrid event, and we had the European Commission together with technologists, and we asked them where they see the role of IEEE and other technologies for circularity. And they said if they had one silver bullet, it would be digital for circularity. So for instance, the digital product passport would be exactly that.
Mm-hmm.
It's about how to implement and also this digital product passport, how to make it interoperable, because it's going to be the same for the whole value chain. And so this is actually very concrete already in Europe, and things that people are thinking of how to implement it. There are already some prototypes. So yeah, that's of course standardization is going to be an important issue there as well, but also technical solutions, tools.
Thank you. There's one more question I'd like to ask, because we only have time for maybe this one, because I think it's kind of an interesting one. How is IEEE developing or encouraging and informing future client engineers that are currently in school prior to universities? This is kind of like a STEM outreach on IEEE and our involvement in sustainability and climate change. Anyone have a comment on that?
So we do have a program called tryengineering.org that provides essentially lesson plans. Lesson plans for teachers that are freely available around the globe. We also have IEEE Reach that has lesson plans based on technology development in the past. And the IEEE has chosen to talk to teachers, quote unquote talk, as opposed to directly to the students, because it has a larger impact. And so if anybody has other class lesson plans that they would like to add to tryengineering.org and trycomputing.org or Try Engineering Together, then we would be absolutely delighted to feature those as well.
Well, with that, I think it's going to have to be our last comment here. And I want to thank all of our participants today. I think they're great presentations, really good questions from the audience. Thank you, everybody. And as I understand it, these questions are going to be, for those people that ask questions, we're going to save them and respond to them offline. So thank you very much, everybody, for participating today. And we're glad to be able to talk to you about this important topic.